Diabetes management is one of the most challenging aspects of improving population health. New technology has allowed healthcare providers to track their patients' blood glucose levels in real time, but current tools have poorly organized the influx of patient data for providers to draw any useful and actionable insights. In the past year, Penn Medicine has obtained data from patient and their flow sheets, which led to questions on how to use, interpret, aggregate, and present this data to providers. To address this problem, our team has developed a web dashboard for Penn Medicine providers to display a patient's monthly blood glucose levels to help make immediate clinical decisions. One of the unique features of the dashboard is its ability to autonomously classify a patient's blood glucose readings based on their relative meal times into one of the 4 different categories: fasting, preprandial, postprandial, and random. To do this, we collect 2 streams of data from the diabetic patients. The first stream of data we collect is a patient's raw blood glucose data, which will be timestamped as soon as the patients measure their blood glucose levels. During the pilot program in March, patients were given Bluetooth glucometers that automatically sent the raw blood glucose data to the iPhones, which then sent the data to the EMR. The second stream of data is their mealtime data, which is simply timestamps of when patients ate their meals. This data will be collected via manual entry from patients through an app on their iPhones. With our classification algorithm, our web dashboard displays the data in a way that is easy for providers to draw meaningful and actionable insights.
A patient's blood glucose data are classified into 4 groups. Fasting, which are blood glucose data recorded 0 to 1 hour before the first meal of the day. The first meal of the day must take place after 3 a.m. to accommodate individuals with irregular working schedules. The second classification is preprandial, which are blood glucose data recorded 0 to 1 hour before any meal excluding breakfast. Third one is postprandial, which are blood glucose data recorded 1 to 3 hours after any meal. And the last one is random, which are all other blood glucose data. The web dashboard is divided into 2 levels, a population level view and a patient level view. The population level view, displayed on the screen, provides a tabular summary of a provider's patient's blood glucose levels in a selected month and year. When the page loads, the selected date defaults to the current month and year. For each patient, the table lists the blood glucose averages for each of the 4 blood glucose classification groups: fasting, preprandial, postprandial, and random. The table also lists the blood glucose average for all of the patient's blood glucose data, regardless of classification, under the total average column. Below the blood glucose averages, the table displays the number of blood glucose data points used to calculate that average. Lastly, the table calculates a priority score for each patient, which is simply the patient's blood glucose data standard deviation over the mean. The higher the priority score, the less controlled are the patient's blood glucose levels. The table currently displays NA and N equals 0 for all the entries, which simply means that there is no blood glucose data for any of the patients in the selected date. On the left-hand sidebar, there are search functions that filter the table. First, providers must select the date of interest. We are going to skip the blood sugar classification checkboxes for a minute and look at the above and below text boxes. These text boxes provide the option of searching for patients who have had blood glucose levels above or below a user input. If any one of these text boxes is blank, then it simply ignores that search criteria. For example, I can search for patients who have had blood glucose levels above 200. I can also search for patients who have had blood glucose levels above 200 or below 100. The last search function allows providers to search for patients whose monthly average blood glucose level has increased by user input. For example, I can search for patients whose monthly average blood glucose level has increased by 50 between February and March. Now let's return to the blood sugar classification checkboxes. This allows providers to restrict their search functions to certain blood sugar classifications. So let's uncheck fasting and random. And in this example, I am searching for patients who have had preprandial or postprandial blood sugar levels above 30. Once a provider is happy with his or her search functions, he or she must click Apply to filter the table. The clear button simply erases the user's entries. If I click a specific patient in the table, I can see more information about that patient in the patient level view below. The patient level view provides a graphical plot of a patient's monthly blood glucose data points in the selected date. We can see all the patient's blood glucose data color-coded by their classification group, which can be a bit overwhelming. I can therefore filter which blood sugar classification I want to view by checking these checkboxes in the left-hand sidebar. In addition, I can judge how well a patient is managing his or her blood glucose levels by comparing them to adjustable patient target goals represented by the blue shaded area on the graph. Lastly, if I'm interested in viewing a patient's blood glucose average levels for each of the blood sugar classification, I can do so. The average lines, which are also color-coded by blood sugar classification, are represented by a broken hashed line on the graph. Below this graph is another graph of a patient's blood sugar trend line over the past 3 months from the selected date. At the very bottom is a table that summarizes all the information displayed in the first graph, detailing information such as the total number of points for each blood sugar classification, and also the percent in and out of range of the blue shaded area, and also information such as the maximum, minimum, and mean value of the blood glucose data, and also standard deviation, just to see how well each patient is managing their diabetes glucose levels.